A very good evening to all the respected
Andrea,
dignitaries. Yes, sir.
start now.
Okay, sir. A very good evening to all the respected dignitaries, esteemed resource persons, faculty members, and researchers, and dear participants. It is indeed a moment of great pride and pleasure to extend a warm and heartfelt welcome to everyone gathered here for the 10th session of ATAL FDP. Your enthusiastic presence reflect a shared commitment to continuous learning, academic excellency, and professional growth. Today's session focuses on a topic that lives at the heart of sustainable development and intelligent transportation system, AI-powered electric vehicles, trend, challenges, and opportunities. The global transition towards electric mobility is no longer a distant vision. It is an ongoing reality. When combined with the artificial intelligence, electric vehicle evolved into the intelligent system capable of smart energy optimization, predictivity diagnosis, and maintenance. Intelligent battery management, autonomous decision making, seamless integration with smart grid. However, along with the rapid advancements comes technical challenges, infrastructure limitations, data complexity, and resource gaps. Understanding these dimensions is essential for educators, researchers, and students to contribute meaningful to this transformative field. Today's session promises to provide deep technical insights, research perspectives, and future opportunities in AI-powered electric vehicle technologies. It's my it is now my esteemed honor and privilege to introduce our distinct resource person for the today's session. Dr. Veera Nagi Reddy is a distinct academician, researcher, and expert in the field of artificial intelligence and control system. With a wealth of experience in education and research, Dr. Reddy has established himself as a leading voice in his area of expertise. Dr. Reddy holds a bachelor degree in engineering from Sri Venkateshwara University, Tirupati, followed by master's degree in technology from Jawaharlal Nehru Technological University, Anantapur, and later earned his PhD from the Jawaharlal Nehru Technological University, Kakinadu, establishing a strong academic foundation in his area of expertise. Dr. Reddy has had an illustrious teaching career spanning over 19 years. He had taught more than 20 courses at the undergraduate and post-graduation level. He began his teaching career as an assistant professor at Sri Sai College of Technology. Dr. Reddy is working at the University of Technology and Applied Science Solitude of Ohms. Dr. Reddy has published numerous papers in reputa- reputable international and national journals. He has also served as a reviewer for several Web of Science and SCI journals. Dr. Reddy research interests include artificial intelligence, productivity control, and smart grid. He has received recognition for his contribution, including the Best Reviewer Award from Publisher. We truly honor and delighted to have such an immense academician and expert with us today. On behalf of organizing committee and all participants of ATAL FTB, I warmly invite you, sir, to and take over this and kindly take over the session. Thank you, sir. The visual stage is yours.
Thank you, madam, for a nice introduction. Good evening, everyone. I am Dr. Veeranagi Reddy. I am the professor in Department of Electrical Electronics Engineering, University of Technology Applied Science, Ibri, Oman. Today, I will be speaking on the topic AI-powered electric vehicles, that is trends, challenges, and opportunities. Before going to start, let me share my screen. and I better switch off my camera for time being. By that I can get good signal. Can you see the screen? Anyone can confirm,
Yes,
please?
sir.
Okay, thank you. So today I will be speaking on the topic artificial intelligence powered electric vehicles. What are the trends, challenges, and opportunities as part of ATAL sponsored 6 days online faculty development program that is organized by Department of Electrical and Electronics Engineering, PSNA College of Engineering and Technology. So, as priori, I would like to extend my sincere thanks to the management of PSNA College of Engineering and Technology and the principal and the head of the Department of Electrical and Electronics Engineering and all organizing committee members. So, thanks for inviting me as a speaker. So, this is the
Please
topic
go ahead.
I'm going to share with you. That is AI powered electric vehicles. What are the trends, challenges, and opportunities? So, these are the topics we are going to cover in this session of 1 hour 30 minutes. First, we'll see about what is the introduction of artificial intelligence and electric vehicles. What are the different AI tools that are applicable for electric vehicles? And what are the difference between a traditional vehicle, electric vehicle, and AI enhanced electric vehicles? And then I will talk about AI applications in EV subsystems and what are the challenges and opportunities in the field of EV market. And at last, you can see some case studies. If time permits, I will show you a small project that is a internal research grant funded project what I have done in the last academic year. So let's start our presentation with the slide that so as we know that most of the innovations that are being invented are inspired from the nature. So, for example, the design of medical injection needle, which is painless. So, it is inspired by mosquito proboscis, so which is actually thin and sharp and easier to penetrate with our skin. So, by seeing that, the researchers have been invented the painless injection with micro needle. And high speed trains, the bullet trains, actually as inspired by Kingfisher beak, how the Kingfisher will dive into the water without splash and catch the fishes with high speed. So, by studying the structure of the Kingfisher beak, the bullet train, high speed bullet train have been invented, so which will run at high speeds without any noise during the under the tunnels. And there are many optimization algorithms being invented in the field of engineering. So like ant colony algorithm, particle swarm optimization. So the ant colony algorithm has been inspired from the moment of ants, how they make colonies. And particle swarm optimization have been invented from the behavior of swarms, how they can search the food in shortest path. And the algorithm have been developed from the inspiration of particle swarm. And today's topic, that is artificial intelligence. So the artificial intelligence also have been inspired by human brain. Of course, we the people, human beings, indeed part of nature. So we are a product of natural evolution, of course. So the deep learning and artificial intelligence, these are inspired by human brain that will get into the in deep today's session. So these are the nature inspired innovations that we are being come across. So if really have any problem, so if you look at the nature, surely nature will give the solution. So in terms of technology, and let's start the what is meant by AI, artificial intelligence. So this artificial intelligence enables missions to learn, think, and make decisions by mimicking human cognitive functions like problem solving, pattern recognition. So which is actually inspired by human brain. So actually, why AI is important today? AI is very crucial nowadays because it leverages explosion of data. It harnesses advances in computing power, and also it enables the real-time decision making. And also the AI can drive the automation and efficiency across industries, especially while dealing with the complicated applications. How we can transforming our life and work. So coming to the what are the different types of artificial intelligence techniques? Actually, the artificial intelligence types we can categorize into three. That is narrow AI. So actually, this is the AI which has been we started long back. Actually, that is narrow AI, or we can say weak AI. So which performs the tasks like image recognition, voice assistance, like we can use Siri or Google Assistant, whatever. Next, we have moved on to general AI, which is strong AI. So which can understands and learns, and also it applies the intelligence across the tasks, like exactly the like humans. And last one is now at present what the AI is emerging, that is called super intelligence AI, behind human intelligence. So it exceeds the human cognitive abilities in all aspects. So as we know that our human brain can process the information only at the speed of milliseconds, you can say kilohertz, whereas computers are faster in response in terms of gigahertz. So with respect to the speed and as well as the storage capacity, so the artificial intelligence is going beyond our human intelligence. So this is the journey of artificial intelligence. So coming to the branches of AI, what are the different branches of AI? So there are majorly four branches of artificial intelligence. So that is neural networks, machine learning, robotics, fuzzy logic. So neural networks, it mimics the human brain structure exactly for pattern recognition and learning. How exactly our human brain structured with the neurons? As we know, our human brain is very complex in structure that nature has given to us. Only human beings have the that much complex structure. Hardly we have 10 power 14 neurons in our human brain, and each neuron is interconnected to the 10,000 neurons. So very complex structure. Because of that complex structure, we have so many abilities, like we can learn, we can create, we can think, we can adopt, we can uh, do the things, emotions. So no other living being has this type of human structure like animals or other birds. So that is the God gift for all of us. So now, with the same structure, now there is a artificial neural networks have been invented, and there is a learning, machine learning, and deep learning. So these are the systems to learn from data, and they can improve over the time. And fuzzy logic is the logic actually which can think logically. So based on the environment, so it can adopt the system. And the robotics, these are the artificial intelligence powered missions which are interact with the with, and also they can adapt to the environment. So these are the major some branches of AI that we can come across. And what is the difference between machine learning and deep learning? So actually, the artificial intelligence is actually the one, if you assume as one set, the machine learning and deep learning are the subset of artificial intelligence. So based on the complexity of the problem, you can use these learning algorithms. So suppose if problem complexity is less, you can go for the machine learning. If you want to deal with the data like numbers or values, you can go for the machine learning. So if you want to deal with the patterns like images or videos, so you can opt deep learning, which is very effective and efficient to solve the problems. And as we know that actually to implement or develop any AI app nowadays, every minute there is one app is developing and coming to the market, irrespective of the specialization, whether we are electrical or civil or mechanical or whatever. So everyone should have the AI skills. Without AI skills, we cannot survive in the market nowadays. So we need to develop the AI skills. We don't think, well, I'm electrical, I don't want AI skills means if you are not updating the AI skills, you will not be survive in the market. So as in that point of view, nowadays why the AI is trending in the market. So because of big data, nowadays the large amount of data they are creating, and we are consuming. So like nowadays we are using so many social media, and also the Google data, real time data we can access from the Google or many websites. So the big data is one of the most important part of the artificial intelligence. Without this, we cannot uh, properly develop the artificial intelligence app or model. So this is actually the analytics for the past 10 years. If you notice how this data usage is, trending, increasing year to year. So starting from 2010, only 2 zettabytes of data have been created or captured or copied or consumed. This is the total data, and is drastically increasing. Coming to 2025, now 181 zettabytes of data that has been created and used. So that now the AI is advancing in more rapid speed because of big data availability. So a lot of data available in the cloud, that is not matter. So that this is one of the main reason to rise this AI in rapid speed. So these are the basic differences between machine learning and deep learning. So machine learning is just if you give the input, and also we need to do feature extraction. So for example, you are giving the car as the input, you have to give the extraction like wheels, windows, driving seat. Uh, as a after extraction, if you give this data to the neural network, so it can based on this training, it will train and it will save the features of this input, and it will store. So once it train for this image, if you give the same input later, so whatever the data already it is trained, it will map the input and output, and it will give it's a car. So this is machine learning. So the data will be given as the separate numbers or values, such a way it will train the data. So whereas in the deep learning, so the feature extraction also can be done by the deep learning itself. That means in this the neural network what we are using have multiple layers. Here if you notice here only one input layer and one output layer and only one hidden layer. That's it. So whereas in the deep learning, so here you can see two hidden layers. For sake of understanding, we consider here only two, but it may have more than two also. So based on the complexity of the problem, you can consider n number of hidden layers and one input layer and one output layer. Because of this number of layers, it can do feature extraction also by the network itself. And based on the input, it will divide this input image into pixels, and it can fix the weights, and it store the output. So when you can give this input later, immediately it will give the output as the car. Same like our human brain, how we learn the things at childhood. By birth our brain is empty box. How you are learning things by experiencing the outside world. From our parents, we are learning so many things by seeing the neighbors or our external environment. So we are going to adapt and learn so many things. Similar way, so the neural network also will train, and accordingly it will perform the functions of pattern recognition. And actually, in machine learning, there are three types of machine learning techniques, that is supervised learning, unsupervised learning, and reinforcement learning technique. So what is supervised learning? It is actually trained on labeled data. That means we need to provide the both input and as well as the target value. Accordingly, it will fix the weights for that input output. Whereas unsupervised learning, it finds the patterns in unlabeled data. So you can give only input, and accordingly it will make the data as clusters. This you can use in classification application. So whereas reinforcement learning, it learns through trial and error. So there is a some data will be labeled data and some data will be unlabeled data. So it will learn the things by trial and error method. So like some data will be with the help of a teacher or without like a teacher. Usually the students can learn with teacher and without teacher. Same way the reinforcement learning also can learn the things. So this is the discussion regarding the supervised and unsupervised learning. So here see supervised learning method, we are giving the data as the label. We are giving both input image and as well as the output text. So it is going to train this image as the duck. If you ask the later, if you give this image and ask it, this model will say it's a duck. So other than that, if you give any image, it will say not duck. So such a way, the supervised learning can process the data of training. So whereas unsupervised learning, the data which we are providing is unlabeled, just we are giving inputs without any target values. So it will make as the clusters. For example, it will make these are all as the birds and any another images, it will be treated as separate, right? This is about unsupervised learning. So whereas reinforcement learning, so mixing of both these two is by trial and error method, it will going to fix the outputs and weights. This is actually the human brain structure. You can say this is the schematic of biological human brain, from which we can develop the artificial neuron. So in our brain, this is actually one neuron, what you can see on the screen. Like this, our brain has 10 power 14 neurons. The main micro part of human neuron is nucleus. So this is actually the micro part of the neuron, surrounded by cell body. So this is the cell body actually receives the inputs from outside world through our eyes and many parts of our body like nose and ears. All the data will be here make aggregated sum. Based on the strength of the input, it will how strongly you are taking the input accordingly. So it will add the signal and then it will activate the neuron. All these inputs can be received from the dendrites, and this data will be transformed to the another neuron through axon. This is the long cylindrical structure. So it will transmit the data from one neuron to another neuron, and the synapses are the actually the part of the neuron where they change the behavior of the network. So here only the weights will be updated. So for example, in morning time, our mind will be fresh. Whatever the data giving, our brain perfectly process effectively. So evening time, our brain will not perform that much effectively. The reason that the threshold value will be more. So if you give the strong input, then only our human neuron will fire. Then it will data will be transmitted to the another neuron. Otherwise, the data will be stopped here itself. So similar to this biological neuron, there is a artificial neural network have been developed. These are the inputs like dendrites in biological neuron. These are the weights similar to the synapses, and this is actually the sum. This is called cell body. It will receive all the inputs, including bias, and it will make this sum, weighted sum. And there is a activation function. This aggregated sum will be weighted sum will be compared with the threshold value. That is called activation function. If it is more than threshold, it fires, means the neuron process the information. So this is how the artificial neuron. So actually, what are the characteristics of AI? Like our human brain. So our human brain has the characteristics of like learning, adoption, input output mapping, and as well as the emotions. Similar way, the artificial intelligence have some characteristics like It can learn by using machine learning and deep learning. If you provide the data as input and output, it can learn. And the artificial intelligence can understand the natural language, and it can also have the computer vision. So through cameras, it will receive the images and videos, and it can process. So it can do automation and the data analytics and decision making. It can make the decisions, and it has the capability of analyzing the data. And robotics, this we already discussed. Robotics is actually the AI, artificial intelligence trained mission. So these are the characteristics of artificial intelligence. So this is the structure. Already we have seen this in the earlier slides. This is called deep neural network, which has two hidden layers. The number of hidden layers will be depends on the complexity of the problem. Suppose if you are processing the images or videos, this number of neurons and layers will be more. If a problem is very simple, so the number of hidden layers and number of neurons will be less. That depends on the complexity of the problem. So this is the back propagation algorithm. To train the network, the most popular, generally used algorithm is the back propagation algorithm. How the network is going to train. So when it receives the input as a vector, so it will first process in forward direction, like it will receive the input and it will make the weighted sum and it will apply the activation function. That means comparing with the threshold value. Then it fires, it will give the output. That output will be given to the hidden layer. Same process will be repeated, and then output layer. Then you can get the final output. So this output, this is called the forward path. This output will be compared with the desired value, target value. And is there any error? It will adjust the weights W and V. These are the weights. This will be updated. So this error will be propagated back. It distributed to the all layers, hidden layers, and as well as the input layer weights. So that's why the name of this algorithm is back propagation algorithm. So this error will be based on the error, it will adjust the weights, and based on the updated weights, it will calculate the output. Again, it will compare until error zero. This process will be continuous. So this type of training algorithm is called back propagation algorithm, which we can use frequently in deep learning neural networks. And what are the best programming languages for artificial intelligence? There are many programming languages are available. So out of it, the best one is Python, because it's easy to learn and it is simple syntax, and as well as there are many libraries and frameworks available in Python. And also you can use Java, which is a good choice for AI development. And Lisp, it is one of the oldest, and also it is most suited for developing AI app. And Prolog, it is a logic programming language actually. So by this you can develop any AI application. And R programming, this is the comprehensive statistical language. So in order to develop the new ideas, you can prefer the R programming language. So out of this, you can usually prefer the Python because it's very easy to learn. As a electrical, other than computers, specialized engineers can use the Python because it's very simple syntax, and also many libraries available in Python. Even we are very familiar with the MATLAB. as electrical, mechanical, and other specialized researchers have familiar with the MATLAB. You can also use the MATLAB for artificial intelligence. So recently, the artificial intelligence has been integrated to the MATLAB. So by using MATLAB, also you can develop the artificial intelligence apps. So you can convert the MATLAB file into TensorFlow, convert, and you can import to the TensorFlow, and you can work again. You can get back to the MATLAB for analysis of your model, and also ONX. So this also same like a TensorFlow. You can convert, and you can import to the ONX, and from that other frameworks also you can transfer. And PyTorch is one of the important library where you can develop AI models. So from the PyTorch models, you can transfer to the MATLAB, and you can analyze the models. So these are the just brief about artificial intelligence. So now coming to the electric vehicles. So what is electric vehicle actually? What are the major parts of electric vehicle? So as we know, the electric vehicle is it doesn't have the IEC, that is internal combustion engine. So it has the electric motor, and there is a battery for storing the power, and we have the inverter, so to convert AC to DC, and there is a controller which manages the power flow and as well as the speed, and as well as the different driving modes and the condition of the vehicle. Everything will be controlled. For that we need a controller. These are the major parts. In addition, so there are the converter and onboard charger for DC battery charging, and there is a thermal system which is very important, which regulates the battery condition, that we will discuss in depth later, and charging port. These are the major parts of the electric vehicle. Now we can apply the artificial intelligence to any part of each part of this electric vehicle. So let's see how we can, and why we need actually the artificial intelligence for EV vehicles. So actually, the major concern of electric vehicles is actually this concept of EV have been around for a while. However, adoption slowed down about 5 years ago due to challenges like battery limitations and lack of charging infrastructure. But recently, so there has been a significant pickup in the trend. You can see the more cars on roads. So because of increased charging stations, and as well as the advancements in battery management system. So due to these reasons, now you can see more vehicles on road, EV vehicles on road. Still further in future, because of this artificial intelligence, so completely we phased out the conventional vehicles surely in future, because of the fossil fuels may disappear after years. Surely we have to depend on the EV vehicles, electric vehicles. So keeping this point in view, like battery management system, and range anxiety and degradation of some challenges. So this AI can deal with the real-time data also. So keeping these points in view, so AI is necessary for electric vehicles. So this actually the artificial intelligence, it is acts as a brain. That means it take care of driving and safety. like it can detect the objects like cars, people, or any obstacles on road, and also it can respond for the any disturbances, and it can predict the pathing. That is called anticipating moment. It will anticipate the moments, everything. It eliminates the range anxiety, also anxiety. For example, if it is a file fuel you are using, after for a few kilometers it will you are searching for the petrol pump. So there is a more anxiety whether we can reach with available fuel with that station or not. We can travel these kilometers or not. This and all more stress on the us. Now this can be replaced by artificial intelligence. It will take care of everything. So now our brain is free from all those things now. That's why the AI can act as a brain, and also it acts as a doctor for battery point of view. So it will take care of battery. So it will predict the maintenance schedule based on the different sensors, and also it will reactive the cooling with the prevent degradation. Actually the battery should start always with some temperature, for example 25 degrees Celsius. Suppose during the winter time the temperature is 5 degrees during morning time, so there will be a more stress on the battery while starting. So this type of challenges and all will taking care of artificial intelligence. It will automatically adjust the temperature of the battery, and also this AI acts as the energy manager, like range and charging. So actually for cars, so there is a technology, a grid integration. So grid to vehicle and vehicle to grid technology, so that energy management can be taken care of artificial intelligence, that we'll see in the coming slides. And also the artificial intelligence as acts as the assistant. So this actually guide us the exactly the path, optimistic path to travel from one place to another place. And also it will create the generative AI cabin. It will check the condition of the driver, whether he is in active or drowsiness, whether he is sleepy. Everything it will be monitored. Accordingly, it will make it active. So that is called generative AI cabin. So these are the features of AI that we can implement in electric vehicles. So these are the let us see what are the AI tools in EVs. As we know, all these AI tools usually we will come across every day to life. So these are the AI tools that we can use in our academics, like ChatGPT, DeepSeek, Gemini, Copilot, Perplexity, Elicit. These are the actually the AI tools that are being used for our academics, like for doing research, writing the research paper. So we are using Elicit, Perplexity based on our need. Whereas coming to the EV vehicles, there are some AI tool built here. So that is we can use for vision. We can use for YOLO, OpenCV. So these are the tools that you can use for computer vision. So for battery, so we can use MATLAB and Siemens. These are the AI tools as we discussed. The artificial intelligence has integrated to MATLAB. So now we can do so much research on battery management system by using MATLAB. And coming to the design part, so we are going to use many tools that range through light weighting. So nowadays, the weight is the enemy of range of EV vehicle. So we have to reduce as much as possible the weight of the vehicle. So by that we can optimize optimize the range of the vehicle, maximize the range. And there is a tool UX which will act as the co-pilot. It will interact with the driver. It will predict and it will guide the exact path that we will see in the next coming slides in detail. These are the AI tools that we can use as primary benefits. So, what is the role of AI in addressing these challenges? As we know, the artificial intelligence can deal with the real-time data. It can analyze the real-time data, and it has the enhanced accuracy compared to the traditional controllers, and it can recognize the patterns like our human brain, and it has the predictive capabilities based on the past data. So once you train the past data of as a labeled data or unlabeled data, so once it trained, it can predict the feature. And proactive maintenance. So this automation and adaptability. So it can adapt based on the changes in the environment. So this is actually the role of AI in in addressing the challenges what we come across in our day-to-day life, especially in EV vehicles. So let me explain one example of computer vision, how we can use this computer vision, the AI tool of YOLO for light detection. So here, this is the traffic light. So the electric vehicle has to detect this traffic light. How it can? So the camera will capture this, and it will be given to the AI model of EV vehicle. So irrespective of the environment, lighting conditions, either it is a night or it is a adverse lighting conditions also, it can process. So just it will make this image into small pixels. So by using YOLO version 8, so YOLO has been, there are different versions available in the uh, cloud, version 8, version 10. So this YOLO can divide this image into pixels, and it will process, and then it will exactly give the traffic light color, whether it is a red or green or yellow. So this is 97% accurate. So when you notice this red light, immediately the AI assist the enable the regenerative braking. So by using the regenerative brake, when you see the red light near the traffic light, the vehicle has to stop. So this artificial intelligence tool can enable the regenerative braking. This is the way how we can use the tool, first tool for a computer vision. And another AI tool that I'm going to emphasize is that generative design for lightweighting. As we discussed, the weight of TV is the enemy of range. So, if you design traditionally, for example, this is the centric shape, so which is designed by human. Whereas here, right side, you can see the generative design. This is designed by the AI, artificial intelligence. So this can exactly see wherever there is a more strain, more tension. So it will make as a solid. If there is no tension on any part of this design, it will make it as empty, whole. So this data will be required. It has to give by the user. So which part of this design will be more tension? Which part of design is part of this no tension? Accordingly, based on the input commands, it will design the structure. So if you see left side, there is a traditional design. Right side, you can see the generative design. So this is almost 20% lighter than this left side traditional design. And bottom you can see this is the battery case. So which is designed by AI, which is 40% weight reduction. And the wheel rims, if you by using the AI, 30% lighter compared to the traditional design. So overall, by using this generative AI for design, so you can reduce the 10% vehicle weight. By that, you can increase the 6 to 8% of our driving range. So this is just examples how we can use the AI tools in EVs. So it is not compulsory, mandatory that only computer, specialized engineers can do research or publish papers on artificial intelligence in EVs. No, not at all. So anyone can, do research on EVs that integrated to by AI. And this is the suspension control arm. See the difference. This is the traditional design, and this is the AI optimative generative design. So this is like it is a completely solid, whereas here, so there are empty spaces, holes. So with this AI generative design, so it is less weight, and by that you can get the more range. You can travel the more distance from less battery charge. So, what is meant by software-defined vehicle? So, actually, in olden days, the vehicle what we are actually using nowadays, so is a traditional vehicle. So, whereas you want to define the software to the vehicle, so we need to use the electric motors. As we know, the electric motor is best respond for the computer software, so that we prefer the electric vehicles. And if you add the AI technology to that EV vehicle, so then it saves the energy, and also it improve the performance. This is actually the dashboard of AI driven vehicle. So it is completely different from conventional cars. So here you can see it is the steering. So here you can see this AI pre-action. So in which you can see exactly the position of the car. It will search the 30 meters ahead. It will identify is there any vehicle ahead of it. Immediately it will initiating the regenerative braking. That everything can be monitored here by AI tool. So there is a camera front side which can capture the lane, and that video capturing will be given to the AI tool inside. So it will process and it will say the signals to the driver. And there is a predictive energy card, so which will gives the information about battery status, how many miles you can travel with that battery. This is the predictive energy card, and it will say so how much distance you can travel and what is the condition of the battery, what is the temperature, what is the voltage, and what is the current. So everything will based on this data. It will be monitor the battery system. And there is a agentic assistant, what we discussed in earlier slide. So it will give the commands to the driver like a pathing. So for example, if it is notices there is a 15 minutes delay, what it is traveling, the vehicle traveling, if it immediately give the command to the driver, and it will ask whether we need to change the route or we need to go. So it will ask the confirmation, and also it will display if you follow this route how much saving, how many rupees you can save. So everything will be. This is the dashboard of AI-driven EV vehicle, and also it uses the terrain, wind, and traffic and driving conditions. That means it will see the condition of the slope of the road, whether it is a hill or it is a valley or it is a what type of road it is, and what is the wind speed. Based on the traffic, it will analyze and it will give the commands to the driver. It will provide the best route. So this data will be collected from the real-time data, and accordingly it will guide, assist the driving. So it is actually more accurate than what we follow actually the meters in traditional EV. So this is AI-based dashboard that you can see in future. And the most important part of EV vehicle and more the challenge is about battery management. So we are going to find the state of battery by using the neural networks, and we can predict exactly what is the status time to time, and accordingly it will make the decisions. Suppose is there any uh, low charge after traveling the 400 miles, for example 400 kilometers, if there is a need of charging, it will say before, well before reaching the point. So immediately accordingly it will plan for charging the battery. So that is called the predictive state of charge. And material discovery also, this generative AI and deep learning, it can formulate the exactly what is the chemicals that will be best for the high efficient batteries. And thermal management is one of the important area where you can focus our research. So these AI models actually predict the temperature and current and voltage. So accordingly, it will take care of the battery thermal condition. As we discussed, this monitors the voltage, current, and temperature, and it will predict the degradation and failures. As a 24 by 7 health monitor always will be there by AI, and predictive health analysis using voltage, temperature, and current, and by that it can be extended up to 30%. So this is the state of charge estimation. So compared to the traditional charging monitoring system, so as of now, what we don't know when our car stops working. That time only we'll check the condition of the battery. But whereas in future, by integrating AI to the EV vehicles, so it will predict, and also it will exactly gives the proper error. Is there any error with the battery? So everything will be monitored. And as a case of traditional vehicles, we can see only the engine symbol when there is a fault in the car, whether it is a engine or somewhere else. The sensor will detect, and there is on signboard you can see some engine symbol that indicates that there is some problem in the car. Whereas in AI integrated EV vehicles, so it will automatically detect, and it will do the maintenance. So by that way, it will always maintains the less than while estimating all these things. There is a more accuracy, that is less than 1% accuracy with AI. So this is actually the most advanced driving assistance system. So as we discussed, the electric motors will respond faster to AI compared to internal combustion engine. So there are many sensors which including that camera, radar, and lidar. These are all continuously recording the data, and that data will be collected by the central AI system. And by using this machine learning, it will continuously predicts the vehicle movements. Accordingly, we can make this safer and smarter. So this is about the state of infrastructure optimization. So in order to optimize the charging infrastructure, so we need to follow the smart charging technique. So which will prevent the charger failures. So by using the artificial intelligence tool, we can make the charger with less failures, even zero failures. And this artificial intelligence enables uh, the predictive maintenance. So it will find the charger failures before it happens. So accordingly, it will make the plan for replacing battery or to charge the battery. So this is actually the AI driven reliability. Coming to the reliability of EV vehicles, this is the condition based maintenance, actually based on the condition of the vehicle. So like vibration or vibration analysis, or it will detect the early motor faults, and it will warn the driver or owner to maintain go for the maintenance. Such a way you can improve the performance of the EV vehicles. And this is the difference between traditional EVs and AI enhanced EVs. So by following all above AI tools, we can increase the range. Actually, the range is static in traditional vehicles. So, for example, for 20 kilometers per hour mileage, like fixed. So, whereas in EV vehicles, it is a dynamic based on AI prediction. So, battery life, it is fixed cycles for traditional vehicles, whereas EV vehicles, it is adaptive charging. It's not fixed. Coming to the maintenance, for traditional vehicles, there is a scheduled maintenance required, whereas for EV vehicles, there is a predictive maintenance. So, based on the condition of the vehicle, so it will say, it will predict the maintenance date and time. So, coming to the safety, so for traditional EVs, this is reactive sensors which we are going to use. So when it happens, it immediately they will active. So whereas in AI enhanced EVs, proactive AI systems, it will predict the that any abnormal situations, and it will prevent from the event, that incident. And they in actually electric vehicles, we need a power electronics. We can do some research on power electronics also, because we need inverters and converters in EV vehicles. So for that, we can use the AI-based power electronic systems. So, for example, for inverters, we can use intelligent inverter switching circuits. We can use, and which saves the energy, and also we can reduce the harmonics and fault diagnosis. Also, we can use by using artificial intelligence. These are the areas where we can focus for the research for in the area of electric vehicles. So these are the key challenges in EV design. Actually, what we already discussed, battery degradation is the main challenge, and the computational complexity, and real-time constraints also to be considered, and data reliability. Whatever the data we are giving for the AI to train, so it should be reliable. So now the getting the reliable data also one of the challenge. So these are the challenges that EV vehicles are facing. Now we can focus on any one area, and we can do the research. So in order to do the research, we need a challenge, I mean problem. So these are the challenges we can focus on, which we can implement AI, and we can overcome all these problems. And the cyber security and safety challenges. This is actually computer related challenges. So regarding cyber security and safety challenges like data privacy, hacking risks, and also safety critical AI decisions. Sometimes AI, whatever the decisions taking, that should be ethical. So these are the some challenges we can work for research. So based on this, these are the research opportunities. So we can do on intelligent control systems, algorithms, and EV grid interaction, that vehicle to grid and grid to vehicle, and latest technology is vehicle to anything, V2X technology. That means whenever there is a excess energy in the car, you can sell it, you can get some money. So that is called V2X technology, either vehicle to vehicle or vehicle to any standalone grid, or vehicle to grid. So vehicle to anything, V2X technology also is latest area topic which we can work. And coming to the career opportunities, so as we discussed, in order to survive in the job market, in industry, or in even in academics, sorry. So we need AI skills. So once as a teacher we know about AI skills, then only we can teach to the students. So we need to always teach the students about artificial intelligence, even though you are teaching missions or power systems or control systems. So we need to integrate the traditional concepts to AI, artificial intelligence. So by that, the students also can aware that yes, so artificial intelligence is the future. They have to explore and they have to use and each and every area of the engineering. So here few career opportunities for with AI. If you have AI skills, you can get the EV design engineer and AI and data engineer and power electronics specialist. You become, and also research and academia. So these are for all this we need the AI skills in future. So future of AI in electric vehicles is it is fully autonomous. So in future it will become full autonomous. Each and everything will be taking care of artificial intelligence and self healing batteries. So it will monitor the battery and properly it will heal all the negative spots. It is always maintained in sweet spot. And there is a AI driven smart cities. In future you can see AI driven smart cities. Accordingly they will make the road infrastructure and traffic signaling also. And at last, while implementing AI, we should follow some ethics in electric vehicles also. We should be accountable for AI decisions. So AI can do anything beyond the humans without sense also. We should be careful regarding that. We should be accountable while making decisions, and bias and fairness. We should be transparent, and also data privacy also very important ethical concern. So here let us see this is some one case study. Suppose in future if you have the AI integrated EV vehicle with you, suppose if you have the trip tomorrow, for example, tomorrow's date is let's assume 8th February 2026, 7th February 2026. You have a trip of 400 miles. You have a journey plan. Need to start at 9 a.m. If you have the AI integrated EV vehicle, just you how this will be implemented. So AI action, AI can you give this command to the your car tomorrow 9 a.m. We have the trip. We need to start our journey. Then what AI can do? It will check the thermal condition of the battery first. By using thermal intelligence, it will check the condition, voltage. I mean temperature of the battery. If it is a very less 5 degrees, or as mentioned less than 5, so it will adjust the battery temperature to 25 degrees. By that, it will avoid the cold start. By that, we can reduce the range, because more charging discharge will happen. That by that you can reduce the range of kilometers. That's why perfectly it will come into the picture, and it will check the condition of the battery temperature. Accordingly, it will adjust the temperature. It will make the battery as normal load stress. So it is the first phase one. Then departure time. At the time of starting your journey, so it will check exactly. It will ask the the passengers or driver that. So what is the that is called agentic navigation. Exactly, it will say by 4 p.m. you can reach this so and so city. Then if you give the command, we need to have the lunch, for example, 15 minutes, then it can plan for the charging based on the battery condition. So based on the what is battery charging bar, accordingly it will make the uh, charging. It will suggest the charging station during that lunch time. It will make it charge. And suppose if you are reaching the highway, then automatically you will hand over this to the autopilot, like, so that will take care of it. And there are 360 degrees cameras, front side camera. It will capture the lane. It will keep the lane always at the center, and any obstacles accordingly before reaching that, it will apply the regenerative braking before 3 minutes or something. And also there are inside cameras. It will keenly observing the driver condition, whether is drowsiness, whether sleepy mode or active, everything. Accordingly it will make active. This is the situation in highway. And smart charge, as we discussed. So vehicle to grid, based on the charging adaptive curves, it will suggest the whether we need a charging or not. If there is any extra charge, that will be you can sell to uh, the grid also. So by that you can get some rupees. So accordingly, it will suggest give the commands to us whether we need to charge or we need to, supply to the grid. So both options, we can get in AI integrated EV vehicles. That is called smart integration. So you can get the dollars or rupees also. So based on the, so finally this makes the optimized life. Now for 5 minutes, let me show one project. I'm planning to demonstrate my project. Actually, I have done one project on AI. The title of the project is Artificial Intelligence Based Intelligent Traffic Signal Control with Dynamic Vehicle Density Detection for Smart Cities. So this is actually the funded by our university, University of Technology and Applied Science, IBRI. So this is the block diagram of the project. Uh, we are keeping the cameras near traffic lights. They are continuously capturing the density of the cars on the road. That means a number of vehicles, and that video will be given to the AI detection tool. It will process and it will going to count the number of vehicles on the road. Accordingly, it is going to set the time. Nowadays, we are following the fixed time for the traffic signaling in cities. For example, road A, road B, road C, road D. There are 4 junction road. Road A we are fixing as for example, 40 seconds. Road B 30 seconds. Road C 10 seconds. This is fixed. Even though there is no density on the road, the others has to wait. By that, so there is a fuel consumption. also that will waste the time of the persons. So in order to make optimum, so here it will count the vehicles accordingly, it will fix the timing, dynamic timing for traffic signaling. So this is actually the hardware architecture. We have used Raspberry Pi 5. You can also use the NVIDIA here. I think NVIDIA is very high, speed computer processor. That is better than this Raspberry Pi 5. So here I used Raspberry Pi 5 as the processor. And here I consider only two roads, because this Raspberry Pi 5 have limits of two cameras only we can connect here. Two ports are available. So that I tested this project for the two roads, two junction road. And here we have one monitor display and LED lamps, red, green, and yellow. This is actually algorithm what we already discussed. It will capture the videos continuously on road A and road B. It will count the number of vehicles. Accordingly, it will fix the time. But here we fix the maximum time 50 seconds and minimum time 5 seconds. Because suppose if there are more vehicles, we cannot make other lanes as keep waiting for long. So there should be a maximum limit. So these are all instructions, we have incorporated in the Python code. So it compare the count and more vehicles on road A. First, it will give preference for road A and green, and road B red. If not, it will make the road B green and road A red. And then it will display the vehicle count also. According to the count, it will set the yellow before moving to red, and then it will make the green light or red light. This yellow is only for alert. So this cycle will be repeated continuously, such a way the traffic signaling will be based on the density. This is actually simulation. We have given one video to the simulation. This is already recorded video. To the tool what I used in project is YOLO version 10 I used. So it is now see here this MP4 video. It is counting. There are 4 persons and cars, 15 cars. There are no motorbikes and truck. There are 3 trucks. So accordingly, it fixed the time. Whereas coming to the hardware, this is actually the hardware setup what we develop. So there is a road A and road B. There are the LED lamps. There is a control circuit inside the box, where there are camera A and camera B is here projected here. Exactly the bottom of the plate. They are projecting the road A and road B. So this is the inside the control circuit. We have used the relay modules also, Raspberry Pi 5, and we use the cameras, Pi cameras. And this is actually the signal logic we followed. So suppose there are 0 vehicles on road, the green time should be 5 seconds, minimum time. If there are 1 vehicle, so 5 seconds. There are 2 vehicles, 10 seconds, 3 vehicles, 15 seconds, and so on. If there are more than 10 vehicles, 50 seconds. This is actually the time which is in dynamic in nature, not a fixed. So indirectly, we are making this traffic control system as a closed loop system, not a open loop system. Usually, we used to say in control systems, while teaching in control systems, we teach to the students traffic control signal is a open loop system. It is the example of open loop system. Now we are making as the closed loop system. Now it is taking the output, it is checking the condition of the output, taking the feedback accordingly. It will fixing the signal. This is for same for road A and road B. This is for road B. Same logic. This is for yellow. In between the transition from red to green to red, there is a 3 seconds transmission time. And this is exactly the variation of vehicle count. It is exactly linear. It is dynamically changing. There are 2 vehicles, 10 seconds. 4 vehicles, 20 seconds. So based on the density, strictly it change the signaling time dynamically. And here you can see the setup, experimental setup, how it is. Here there is a camera. You can see bottom of the controlling box. There is a camera. Here we keep some cars. So the video is capturing by this camera, and that will be fed to the Raspberry Pi 5 processor. Inside we are using the Python, Tony software. We written the code, double the code, and it is counting the vehicles. For that we are using the YOLO version 10. So accordingly, it is fixing the traffic timing. Here you can see it is zoomed display. So for example, here there are 7 vehicles. So 7 vehicles means 35 seconds green time. So this is road B. Road A, there are 2 vehicles. So 2 vehicles, there is a 10 seconds green time. So like this, based on the density of the vehicles, the signal lighting will be adjusting. It's not a fixed. This is the actually the comparison. So how much waiting time we can reduce. So during the low traffic, 23.2% reduced the waiting time. Uneven traffic time, 37.6. Equal density time, 23.1% average time saved. And similarly, this is based on the fixed time. This is based on the AI based control. So based on the fixed time, this is based on the AI based vehicles per cycle. So these are the savings, improvements in the AI based traffic control system. So final conclusion. So AI actually AI is no longer a feature; it's a core of EV engineering in future, and we should be ethical, transparent, and safe. And the future engineers must both their specialized areas. We have to learn AI skills because AI is a key enabler for EV, and since it enhances the efficiency, safety, and sustainability, and there is a strong scope for engineers and for researchers. We can work on EV vehicles using AI. Okay, thank you for listening my speech. It's my honor to all share my ideas with you. If you have any questions, please you can. Yes, madam. Yes, sir. So that's all my presentation. Do you have any questions? Please, you can.
Excuse me, sir. One question in chat box, sir.
Yes, sir.
Was open source data used for project, sir?
Sorry, sir.
Was open source data used for your projects?
Yeah, yeah. No, sir. I use the my own model. I developed my own AI model with the different images, and some are, like toy cars. I used some toy cars also. So I used some images for different. So I trained my own model for data images.
Okay, sir.
Also, you can use the open source data. Also, you can use already pre-trained networks are available. You can use already pre-trained models also, or you can train your own model by using PyTorch.
Okay, sir.
Thank you.
Participants, any other queries?
Hello.
Yes, sir. Prakash, sir.
Am I audible, sir? Yeah. First of all, let me congratulate the speaker. He has really delivered a very excellent presentation. He has given lots of knowledge to us. My question is, sir,
Yes, sir.
everything
Yes,
is
sir.
good. My question is, uh, looking to our Indian condition, specifically, sir, for condition of our roads, which are really very in bad position. And second thing is non-availability of internet in the in between, or even the speed also varies. Net speed also varies. That is the second point. And third point is our driving. It means our drivers are totally indisciplined people. Now, with these factors, I just want to know how far this EV vehicle we using AI modules is really feasible. How far it will be feasible, sir? Just this is my anxiety. Oh.
Yes, sir, exactly. I agree with you. For Indian road conditions, it will take time, surely. There is a now, as per the advancements progressing, our India also should change. Surely in future, our government or whatever, they will make the roads culture which supports our this EV vehicles, yeah, EV vehicles, surely in future. Suppose in long back we have seen the roads are not that much good. Nowadays, see the highways, what you see, some highways are really, they are competitive for other countries, really. We are being developed, sir, surely. In future, there are maybe roads what we can expect as per the, so that meeting the requirements of AI vehicles. Hopefully we'll get it. At present, what you said is, I agree with you. So not at all suits the AI vehicles, but in future, you can expect based on
And
the
Mhm.
market. We have to change, sir. I mean,
Right, right.
surely
Mhm.
to encourage the EV vehicles, AI vehicles, we have to make the system. Otherwise, we are lagging.
And as you said,
Mm.
vehicle to everything. That will be really boon for us. So nobody will be on the road because the battery is not charged or something. That aspect is also good. And another aspect you said, we can even sell the electricity to grid. I don't know how it will be possible. There I had some doubts, sir.
Yes, sir. Already we have the system. Actually, many in my home also I have solar. I am now selling power to the grid, sir.
Mhm.
I mean, I'm getting some money. I have solar grid on top of my rooftop, my house.
Mhm. Right.
Sometimes, when I'm not using it, is now selling to the grid. So
Right,
it
sir.
may come, sir. Surely, in future, it will come.
I really enjoyed your lecture, sir. Very kind of you, sir. Thank you, sir.
Thank you, sir. Thank you very much.
Thank you so much, sir, for your valuable feedback. Prakash, sir. Thank you, sir. Any other queries, participants? Okay. If there are no queries, you can end up the session. Thank you, sir. Thank you very Nagiriti, sir, for your valuable and informative session, sir. We enjoyed a lot, sir. Thank you so much for your great speech, sir. Thank you, sir.
Thank you, sir. Once again, at the end, I would like to thank all the college management and HOD and all coordinators and participants. Thank you all.
Thank you, sir. Participants, the feedback link will be posted in chat box. Kindly fill the feedback form for the session 10. And tomorrow we have the final day. We have three sessions. At session 1 will starts on 2 o'clock. Okay, the first session, 11th session will be started on the 2 o'clock to 3:30 p.m. Then 12th session will be on the 3:30 p.m. to 5 p.m. And 13th session will be on the 5 p.m. to 6:30 p.m. We have tomorrow 4.5 hours, three sessions. After the three sessions, we have a online test and feedback in the time of 6:30 p.m. to 7:30 p.m. So all the participants make sure that you will be available on the online test and feedback session on the time during the time 6:30 p.m. to 7:30 p.m. tomorrow. At 7:30 p.m. to 8 p.m. there will be the validity section. After completion of the online test, we have a validity session in the during the 7:30 p.m. to 8 p.m. So tomorrow we have the three sessions followed by the online test and feedback, and finally a validatory section. Thank you once again. If you have any doubt, you can reach us by in WhatsApp. Thank you. The feedback form is posted in chat box for the 10th session. Kindly fill the feedback form. Thank you. One more announcement. The online test will be through in ATAL portal only, not in the Google form. So all the participants make sure of your ATAL account be ready, because some participants will have the login issue tomorrow. Okay, be ready with the ATAL portal and also change the password if required, because while going to the test the password will not be correct, like that error will become. So make sure of your internet connection as well as login properly tomorrow. The test will be in Atal portal only. There will not be any Google form shared by us. Thank you. If any other queries, you can post in chat box regarding tomorrow sessions. If there is no doubt, you can fill the feedback form and we can end up the session today. Thank you.